A flower pot falls from a windowsill at 25 meters above the sidewalk. How long will it take the flower pot to hit the ground, and how fast is it moving when it strikes the ground? So this is the same type of problem, but just make sure we identify everything correctly. So falls again, falls from something, so VI equals 0 meters per second. Windowsill's 25 meters above, so my delta x is xf minus xi, so that's 0 because it's going to hit the ground, minus 25. So that is 25.0 meters. My acceleration is due to gravity because it's falling down, so negative 9.8 meters per second squared. I'm trying to find how long it will take to hit the ground, so it's delta t. So same process. Delta x equals vi times delta t plus half times a times delta t squared. Vi is 0, so this cancels out. Delta x equals a times change in time squared divided by 2. I am trying to solve for time right now. So again, multiply both sides by the reciprocal. These cancel out. So 2 delta x over a equals delta time squared. Take the square root to get rid of that square, and then you're left with the square root 2 times negative 25 divided by negative 9.8 meters per second squared. To get my delta time equals 2.26 seconds. How fast is the flower pot moving when it strikes the ground? So that's going to be my VF. What is that? So I'm going to erase this. It will happen eventually. So VF equals VI plus acceleration times time. VI is 0. So VF equals A, negative 9.8 meters per second squared, times time. My 2.26 answer from earlier. And my velocity when it hits the ground is negative 22.1 meters per second. So remember, it's going down, quote unquote, so the velocity is negative. A pebble is dropped down a well and hits the water 2.3 seconds later. What is the pebble's displacement? Okay, so that kind of tells you what you need. So I need to find delta x. Hits the water 2.3 seconds later, that's my delta t. It's dropped, so that means my VI is 0 meters per second, yes. Acceleration is due to gravity because it's being dropped, so negative 9.8 meters per second squared. So I have my delta t. I have to find my delta x. So the formula I'm going to use is delta x equals VI times delta t plus half a delta t squared. Again, I'm trying to find delta x, and luckily I'm dropping this, so this is 0. So delta x equals a times t squared divided by 2. And then I'm trying to find delta x. I don't need to rearrange it per se because I'm not trying to find time. So I just needed to plug in my numbers. So negative 0.98 then times 2.3 squared divided by 2. The answer I get for this, I'll put this over here, it's negative 25.4 921, 2 sig figs, so negative 26 meters. Or if I want to kind of say it in a way that kind of makes sense. Remember, negative can also it also implies direction with physics. So this would be 26 meters down. So that is it for now. If you have any questions, let me know, and we will discuss this more in class, and we'll do practice problems then. Take care, guys.